and I probably mentioned this before, if I didn't, I thought it intensely. The unit for joule is a capital J. It is not a lowercase j. There is a difference.
Lowercase j is j.
Well, only put a hat over it.
Lowercase a j.
All right.
And now that we have the change in energy,
Yep.
we also have the non-conservative work. So we can just say that the non-conservative work is 4 joules.
Good. And the total work?
Is 10 joules,
How'd you get that?
because the total work equals change in kinetic energy.
Okay, how else could you get it?
Could you also just add them?
Yes.
Oh,
Either one.
and
And now we have this by the box. Remember Newton's third law?
Are they just the same as the first column, like on the box? Because they're equal. No, there should be opposite of those.
Therefore,
it's just negative.
They're all negative.
yeah, negative 6 joules. Negative 4 joules. Negative 10 joules.
So 5 volts. This is 5 volts. So the explanation there is that, was it Newton's third or second?
Third.
So for every,
What do you mean by that? Because if I'm pushing on the box with 5 newtons of force, the box is pushing on me with 5 newtons of force. Our displacement is the same, but the force that the box exerts on me is the opposite direction of the movement. Or,
I'm confused of what's like the differences between like of the box and by the box.
because you have the kinetic, what's the kinetic energy of the box? Just, that's the preposition to use when you're talking about energy. It's energy of something.
Okay.
When you're talking about work, you do work on an object. So if I do work on this notebook, the notebook's also doing work on me. So the work that it does on me is the work being done by the notebook.
Okay.
Look at it a slightly different way. If I'm doing, if I'm doing work on an object, if I do 5 joules of work on an object, I am, we'll assume non-conservative because I'm not going to exert a noticeable conservative force line. So I do 5 joules of work on that. I'm changing the kinetic energy of it by 5 joules. I'm pumping 5 joules into it. At the same time, it's taking energy out of me. So if I put energy into it, it's taking energy out of me. The energy gets transferred from one object to another. So that's the difference between on and by. In this case, these are all positive. This is the energy being pumped into the system. And this is the energy, the energy that's being taken out of a different system.
so
That makes sense.
can you, this is just for my brain to wrap around it. So a box gains 10 joules. Can you give me like a example of like how a box was punched by Mike Tyson and gained 10 joules? Does that apply?
Okay.
But does that make sense for
Yeah.
the context of it?
Mike Tyson punches the box. I'm assuming the box goes flying in the direction he punched it. So he puts energy into the system. So he does positive work on the box.
Right, okay, I get it. So, and then he lost.
Yeah, the energy doesn't come out of nowhere. It has to come from something.
Right.
So the energy is being transferred from him to the box. So he's losing energy as the box gains it.
and it's, I remember law of conservation of energy? Or am I thinking mass?
That's, no,
That's mass.
no, energy.
Oh, energy.
There is a conservation of energy. It's gotta come from somewhere.
Yeah.
An analogy that's sometimes used is that after you've taken a shower and you're drying off, your body's covered in water, where does that water go? Well, some evaporates, some goes into the towel, some goes into whatever clothes you put on right after that. But the water goes somewhere. Whatever the water was when you stepped out of the shower, that water still exists, just in a different form, different place. It's like energy. If I have a wet towel, that water had to come from something. And in summertime in Columbia, South Carolina, probably the air. Other questions? All right, let's actually apply it to solve the problem, other than just sort of illustrating itself. I have a box that is going to fall, so it dropped from height of 10 meters, let's use a different number, 15 meters. And we get a 3 kilogram box, of course. And after it has fallen 10 meters, when it falls 10 meters, how fast is it going? Not a complex problem, but that's where we're starting. First off, we can do it using the stuff that we've already been, I guess we've been tested on half of it. Let's do a force diagram of object falling.
Okay, gravity. Weight to the grip. Acceleration to the grip. Mass times acceleration to the grip.
Okay, we'll go with that. Otherwise known as,
Weight.
yeah. What else? Okay. So F equals ma. So my weight, mg, let's go through the steps. I'm gonna choose down to be positive. Weight equals mass times acceleration. mg equals mass times acceleration. Acceleration equals g. This should not be a shock that the only force acting on it is weight. It will accelerate at the acceleration due to gravity. What is my initial velocity?
Zero
Give me the whole thing.
meters per second.
All right. My final velocity I'm trying to find, actually I'm trying to find final speed. My displacement,
10 meters.
what'd you say?
10 meters.
10 meters. It's gonna fall 10 meters. Positive, because I said down was positive. Acceleration,
What earth are we on?
let's make it here. 9.8 meters per second squared. And time, I don't know. So therefore, what is that final velocity?
Oh, let's see if I can remember the thing.
Which formula would you use?
Displacement equals initial velocity.
We don't know time. We need the formula that does not have time in it.
I don't know.
The Kate formula without time.
Final speed squared equals initial speed squared plus 2 acceleration dot change in displacement. Or displacement, just displacement, okay.
Or change in position. All right, so this is the formula that we could use here, and so this would be equal to 0 squared plus 2 times 9.8 times 10, which is 196. So VF is equal to, is it 14? Okay. Meters per second. All right, so that's how you would solve it, basically using chapter 2. I threw in the chapter 4 stuff, just why not? Now let's solve it using energy. I have an object going from here to here. Starts out 15 meters above, starts out, it ends 5 meters above. The only force acting on it is the conservative force, so energy is conserved. My change in energy is equal to the non-conservative work. This is E final minus E initial is equal to, well, if I don't have any non-conservative work, what is the non-conservative work? Let me reword that. If we don't have any non-conservative forces, what is the non-conservative work?
0.
So E final equals E initial. It's just taking a couple steps to recognize energy is conserved. Whatever we start with, what we end with. I have 2 types of energy that I care about here. We assume it's not bursting into flames. K final plus U final equals E initial. Try that one again. K initial plus U initial. Now let's get more specific. I'm about to ask that question again. What's the formula for kinetic energy?
1/2 mass V squared.
Really? M. M.
Yeah.
If some people do mass and some people do M, then it's not gonna sound like the chorus of angels.
1/2 mv squared.
See, that was so clear and crisp, such unison, it sounded like a single voice. What's the formula for potential energy? The one associated with weight.
MGH.
Now, you put in plus C if you want to. But it would cancel out immediately, so usually it's just not bothered to write it down. All right, what can we get rid of?
The M's.
All right, every term has a mass in it, yeah, as a factor, okay? M's gone.
The G's. No. Yeah. Wait,
No, not the G.
why not? I see a G on the right and I see
You got a G here, you don't have a G here.
Oh, but they're combined.
Yeah,
I mean, like-
with a plus sign in between that prevents you from canceling it out.
Okay. The V squared? Are they different things? Because they're 2 different values.
That's the initial speed squared, that's the final speed squared.
Oh, the half.
You wanna multiply everything by 2? We can't get rid of the half, but we could multiply everything by 2 and have 2 here and 2 here.
Never mind. That's all we're getting rid of.
Okay. So I got 4 terms now. My equation is now morphed into 1/2 VF squared plus GHF is equal to 1/2 VI squared plus GHI. Which of these is equal to 0?
The right side. The initial one.
Because
There-
I assumed it was like the last one and it was stopped at the very beginning, like someone was holding or something was holding and then started.
Okay, so therefore,
The initial speed was 0.
alright, so that's 0 because it was dropped. Alright, anything else?
Oh, can we say that the initial GH,
The initial height,
the initial height, can we say that is 0?
why?
Because I want that to be the potential energy 0.
That's 0 because Ibrahim said so. That is perfectly legitimate. You are mighty and powerful. And if someone else could have all been equally mighty and powerful if they had spoken up first.
So we can say that just to set the problem like we want it to be. It's like deciding where the problem starts.
You can set potential energy, gravitational potential energy 0 to anywhere. You can set any potential energy 0 to equal to anywhere, but I will say, when we get to elastic potential energy, if you don't set 0 at the equilibrium point, you are just quadrupling the amount of math you have to do. All right. So we now have, this object has no energy to start with, or it has energy if you want C to be something other than 0. So we've got 1/2 V final squared plus GH final is equal to 0. Let's plug and chug. We're trying to find VF. So I got 1/2 VF squared is equal to negative GHF. VF squared is equal to negative 2 GHF. So VF is the square root of negative 2 GHF. Now personally, if you want to plug in numbers earlier, go for it. But now I got a negative under the radical, so that might be of concern. It's nothing wrong with that, but just take note. Now let's plug and chug. I got negative 2 times G. What is the final height?
5 meters.
If you plug 5 in here, you're gonna get a radical.
Negative.
Negative.
Calculators don't like that. Usually. I guess it depends on the calculator you have. Remember, Ibrahim said H is equal to 0 here. So what is the final height?
Negative.
Is it negative 10?
It is.
Oh, negative 10 meters.
There we go. As you go lower, you get a smaller height. That is set, regardless of what you say is the positive or negative direction. So we got the negatives will cancel out, which is good. And so we now have
196. 14.
and we got the exact same answers we had before. Questions before I show another parallel and then show why this is more useful than what we had just done.
So all we did is like redefine the coordinate system so down is negative.
No, we never established whether down was positive or negative. All we did, Ibrahim, his fault. He said where 0 was. And then when you're dealing with energy, as you go in the direction of the gravitational pull, you're going to a negative. You're going to a lower height, so if that's 0, these have to be negative down here.
side, or the positive, or the final, okay, if I made the final height 0,
Right.
then the outcome would be positive?
It better be. If you make the final height 0, so if we establish this is 0, then we would have 1/2 V final squared is equal to G H initial. Because 0 is here, and we started up here, it's positive 10.
Right.
So this becomes positive 10.
You got it.
I'm gonna take this equation, let's see. I'm gonna multiply by 2. And then so I get VF squared plus 2GH final equals 1/2 VI multiplied by 2, VI squared plus 2GH initial. So VF squared is equal to VI squared plus 2GHI minus 2GHF. VF squared plus equals VI squared plus 2G HI minus HF.
Or delta H.
VF squared equals VI squared plus 2G negative delta H.
Negative delta H. And we can, I was thinking like, the G can really just be an A, because it's acceleration.
Plus
It
2, and in essence, it's a dot product between acceleration and displacement.
We have proven.
So basically, that over this cake formula here